So I had this little program thing here all planned out, but I decided that I won't do it this way. I'll show you the first half, but the second half I'm just going to go ahead and do, um, for lack of a better word, live. That way you can see more interactively how it works. So these are just our core comparators, which you probably won't understand unless you've used the previous language, but don't worry about it. We'll cover it in further detail later. We have comparators, which is equal to, which cannot be confused with the sign, which is a single equals symbol. Then we have less than, less than or equal to, or greater than or equal to, which cannot be confused with the reverse, or equal to, greater than, which is even hard to say. So I think it makes more sense and it's more natural. The less than or the greater than, and then the equal sign. Then down here we have data types, which in Python, these are the core ones. It's not all of them, but these are the core. We have floats, which is any kind of decimal, negative or positive. And then we have integers, which is whole numbers, negative to positive. That's including 0. Strings, hello, number, 9, anything in quotes, just anything with single or double quotes. That's including variable names. I'll go into that later. Then we have tuples, which is a compilation, which is a combination, there we go, of various data types, whether they be variables, letters, words, numbers, or what have you. And a tuple is surrounded by parentheses, and a list, which is very similar, is surrounded with brackets. I'll show you the main difference of them later on. And then we have our operators, which for Python, multiplying is done with the asterisk, and raising to the power of whatever is double asterisks. And then we have division. There's two different types of division. I'll go into them a little bit later as well. And then we have addition and subtraction, which is, addition and subtraction. So it's pretty easy. I'm going to go ahead and pull up idle. Fresh copy of idle, I guess. So you should have downloaded this already, the first video we made. So when it comes up, it'll look like this. We're going to be running through the interpreter, so we're not saving anything that we're doing right now. We're just going through the core stuff. So for instance, I just mentioned last tuples and list. So we'll go ahead and make a tuple. You can't use the variable name tuple because that's actually a function in Python. So we'll just call it tup, and we'll make it a number tuple. So it has a 0 and a 7 in it. So now that we did that, whenever we type tup, it will go ahead and print us that value. And now we're going to do another thing called list, but once again, you can't use the word list because that's a function. It makes a list out of things. So we'll make a list now, and we'll put 2 and 3 in this list. So now when we open the list, we have a 2 and a 3. And you'll notice that they seem very similar. They both hold the same data. Now here's the difference. If we index either one of them, so we'll start with list, indexing is a square bracket afterwards with a number. So if I do lis 0, it will print 2, and if I do lis 1, it will print 3. Now, hopefully you've already caught on as to why that is. Indexing is basically grabbing a unit from that variable. So we have lis, which is our stand-in for list, and we want the first element. Now, Python and most other programming languages start counting by 0. So what we see is the first element, 2, and the second element, 3, Python sees as 0 and 1. So when we index by 0, it will print the 2, the first item. And when we index by 1, it will print 3, that next item. Now if we do the same thing for our tuple, and we index to 0, it'll print 0. And we index to 1, it will print 7. Now here's the difference. If we go to our list, which looks like this, so we index at 0, and we make that equal to, by using the operation or the equal symbol, it makes things equal to. So we're going to assign it the value 23, and we press enter. Now when we print that list, you can see that the first thing, the thing indexed at 0, is now 23. However, if we use our tuple and we index at 0 and we make that equal to 23, it'll give us an error because tuples do not support item assignment, which may seem kind of silly right now, but it's basically a security layer inside of a program so you don't accidentally change a value. If it's in a list, it means you can change the numbers. If it's in a tuple, it means it's permanent. You can't change the numbers. You can look at them and you can do math off of them and you can print them and you can do every kind of fun thing like that, but you can't change individual items in it. You can, however, overwrite it with a different tuple, such as 23 and 7. And now when we print it, it's changed. But you cannot, through item assignment, change the value to equal something else. Whereas with list, you can. That's the core difference between tuples and list. Frankly, I don't ever use tuples because I find them annoying. Like, for instance, if you wanted to add 1 to the first part, you would have to use a tuple equals tup index 0, comma, tuple index of 1, put that in quotes or parentheses, and then for whatever one you wanted to do your math to, you would just do plus whatever number you had. And then when you print it next, it's added that stuff to it because you made a new tuple by item assignment with the old tuple, which just to me seems very, very inconvenient when I can instead use a list and I can index that list at wherever I want and just do plus equals 5. And then when I print list again, it's added 5 to 23. See, 23, 28. So I always use list. Alright, let's try this again. Alright, I don't know the clear command for this, so I'll just hold enter a bunch and get that out of my way because it's annoying. Alright, so that's the main difference there. As far as I can remember, oh, strings. I was going to show you something with strings as well. So down here we have a string that we're going to make. Actually, no, we're going to have a number that we make. So we're going to make a number and we're going to set it to 8. Now that we have that, whenever you type number, it prints 8. So now we want to print out that number. So we have a word, our number is, what's our variable name? Oh, that's right, we named it number. So we're going to type in number. And then an exclamatory mark because this is exciting. And we print it. Our number is number. That doesn't make any sense. Now, some of you may know why this happened, and some of you are slightly confused. So I'll go ahead and show you. We had double quotes here, or even if we used single quotes, it really doesn't matter. This arrangement of text was inside of quotes, so no matter what, it will just print what's in the quotes. It doesn't matter if it's a variable name or not, it just takes it literally. The only thing it'll have trouble with is if you use more quotes inside of the quotes. That causes issues. So if we wanted to print number, or 8, we could type 8, like so, but then we really have no purpose whatsoever for having a variable number 8. That would essentially just be a waste of space and time and everything. It'd just be really stupid to do that. So what we can do, however, is we can concatenate our strings. So now we have two strings. We have the first string, our number is, and the second string, exclamatory mark. So that'll print that nice stuff there. Now, if we want to add in our number, we simply type our variable name outside of quotes, number. And it won't do it because it is a string, which we can quickly convert it into a string like so. So now it will convert the number 8, which is an int, and it'll convert it to an str, which is a string. That way it can add. I'm sure you've done this before, but there's a common math thing where you can't add non-like items together. So we have strings here, and we're trying to add them to numbers, and then we're trying to add them to more strings. It's impossible. They're not the same. So str converts it so they're all the same item. We have a string plus a string version of number plus a string. So now, no matter what our number is, we will always print that string. So for instance, we'll just go ahead and make number equal to something else. And now when we print, it'll change along with it, so we can have an intelligent output. The next thing we have is loops and comparators. So we have, first off, the if statement. If statements are structured as so. So if 2 plus 2 is equal to, and we're not assigning, we're using the comparator, which is double equal signs, to 4. Then we're going to do whatever is inside of it. So if 2 plus 2 is equal to 4 is true, we're going to print true. Well, we would have if I would have done that right. There we go. So we're going to print true. Ta-da! For making this easier to understand, we'll just make a variable called x, and we'll make it 4. So if x is equal to, is equal to 4, then we're going to print true, or whatever you want to print. It really doesn't matter. So there we go. Whereas if we change x equal to 9, or even a string or anything else, then it won't print anything at all. So here we did a comparison. We have x, and we check if it's 9, or we make it 9, and then we check if it's 4. If it is 4, then we're going to print this line. If it's not, we're not going to do anything. Now, in a game, you'll typically do lots and lots of comparisons. So you might have, if x is equal to 4, do that. Otherwise, if, or elif, x is equal to 9, then do this other stuff. And the way this works is, if this statement does not evaluate to true, we do the elif statement. And no matter how many elif statements you have, it will always just continue. So I'm going to go ahead and actually show you the rest of these through here. So we run it. The first thing that we have is 2 plus 2 is equal to 5, which is wrong, so it won't do anything. Then we have this one, which 2 plus 2 is equal to 0, which is also wrong, so it won't do anything. Then it goes to the elif statement, 2 plus 2 is equal to 4, which is right, so it prints correct. Then we have this one, which is wrong, and then this one, which is wrong, and then an else statement, which is correct, so it prints correct. An else statement, instead of having another comparating, it will just happen no matter what. So if this didn't happen and this didn't happen, this will, always. If this didn't happen and this did, the else statement won't happen. It's based on everything else. If everything else failed, this is the last resort. It comes in, it tries to fix everything. And then we have while loops. So a while loop will execute everything inside of it again and again and again and again and again until the comparating thing is incorrect. So for instance, while 2 plus 2 is equal to 4, so while true, go in here, print this will never stop, then go back to the top, print 2 plus 2 is equal to 4, and you'll be like, oh, alright, 2 plus 2 is 4, so we'll print this again, and then it'll go back to the top, and it'll happen forever and ever and ever and ever and ever, and it'll never stop. But I went ahead and throw in this thing called break, which is a Python word or variable that's always there. It's a function basically, and it breaks out of a loop. So when it goes 2 plus 2 is equal to 4, true, print this, break. Okay, we're done. And it won't run this comparison again. And then it'll just go out of the loop and print I lied. So this will never stop, I lied. Now a more interactive version of this would be in here, we'll go ahead and make a while loop. So while true, print some gibberish. There we go. It'll never stop. It goes on forever and ever and ever and ever until I press Control C, which is the hard-coded break for a program. If you ever get stuck in a loop and you didn't mean to, you simply press CTRL plus C. And that will break out of the loop. You just press C and it's a keyboard interrupt. It just breaks out of loops. That's its sole purpose in life. So that's why that happened. Whereas where we put break, it broke out. I didn't have to do a keyboard interrupt. Then these two here are probably my favorite. They're for loops. I use them for everything. So right here we have a list of numbers, 0, 1.2, 3, etc., etc. A for loop goes through the list, picking out the first item. So for I in list of numbers, this is an assignment. It goes to 0, the first item in the list of numbers, and it makes I equal to 0. And then inside of this function, or this loop, it does whatever's in there. So print I, or print 0. Then it goes back to the top, and it reassigns I to the next thing in the list, 1.2. So I is now equal to 1.2. Print I, which is 1.2. Goes back to the top, does the same thing for 3, and then I is now equal to 3, so it prints 3. 0, 1.2, 3, 4.2, and 0.0. You can also do this with words. So for word and list of words, print word. Now word could be anything I want. It's an assignment. It doesn't matter. I can name it whatever I want. So if I named it Bob, or I named it whatever I wanted to, it doesn't matter. As long as it's a variable name, it works. Doesn't matter how long it is. It doesn't matter if it's a single letter. So for this instance, it goes to the first item in the list, which is monkeys, sets that to word, and then it prints word. Then it goes to the second value, grabs R, and prints R. Grabs the next value, cool, and prints the next version of cool. So you have monkeys are cool. And then down here we have this last one, which threw in a bunch of numbers, and you'll notice that those printed as well. It literally just takes whatever is in that list and it prints it. So that concludes today's video, and basically that was just the core logic of a programming language, of any programming language really, so that you could program your own stuff and have a little bit more of knowledge of knowing what is going on in the next video I make, which will be yet another game that we'll make, except instead of being a random number, it will be a random code. Have you guys ever played what's the name of it, Breakout or something like that? It's not the one with the cubes on the top. It's a number game. Code Breaker, that's what it's called, Code Breaker. Basically, the computer will pick a series of 4 numbers, so 2, 3, 4, and 1. Then you will guess a series of 4 numbers, so you guess 3, 3, 3, 3. Then the computer will tell you you got this one wrong, you got this 3 correct, and you got this one wrong, and you got this one wrong. And then you'll make another guess. So this time you guess 1, 3, 5, and 6. And it'll go through and it'll say, well, you got this one wrong, you got this one right, you got this one wrong, and you got that one wrong. And you continue going on until eventually you guess 2, 3, 4, and 1. However, this is no fun if you don't automatically lose eventually. So we're going to put a leveling system similar to what I did in my version of the guessing game. The other thing I'm going to do is I'm going to have multiple difficulties. So for easy difficulty, there won't be a timeout. For normal mode, there will be a timeout. And for hard mode, there'll be a timeout the same as normal mode, except in hard mode, it won't tell you what one you got correct. When the code is 1, 2, 3, 4, and you guess 1, 2, 3, and 5, it will tell you you got 3 right. And it won't tell you what 3. So you don't know if the 2, 3, and 5 were right, the 1, 2, and 3 were right, or whatever. It's just less descriptive on what you got right. So this should be a fun game to do. You guys could feel free to play around with it and, see how far you can get on your own. Kind of make whatever version you want. And then I will show you how I did it in my next video. And like I said last time, make sure you tell all your friends how stupid these videos are and how utterly, stupid they are, and try to get them to waste their life watching them just like you. Even though I have currently 1 subscriber. But don't worry, I'll be faithful there. I have this 1 subscriber, and I guess I'm going to keep making videos for this one dude. And hopefully one day I'll have 2 people to make videos for. And then I'll feel much less bad about myself. I'll feel happy for once. You guys want me to feel happy, right? What do you mean no? That's it. I'm done.